Alrighty, let's see what we got here. Looks like we have an easy smallest number with all set bits. All set bits. You're given a integer, positive integer n, turn the smallest number x greater than or equal to n such that the binary representation of x contains only set bits. Contains only set bits. N is 5, 7. Alright, so the binary representation only contains set bits means all ones, right? Okay. Well, okay, this is more, this is for binary numbers. Basics include 1 followed by zeros. Will translate into a power of 2. And then a bunch of ones translate into power of 2 minus 1. Some power of 2. And you can think of the logic there is because adding 1 to that binary value will has a sum of 1 with a bunch of zeros, right? This is like if you have base 2, it's like that because of 1s and zeros. Base like 10, it's like 9s. If you have a bunch of 9s, which is the biggest single digit in that base. If you add 1 to it, it becomes like 1 followed by a bunch of zeros because zeros is the smallest digit in that base. Anyways, so basically what this is asking, so as that is the case, going from n to the return value is equivalent to finding the next value of 2 to some power of x minus 1 that is greater than or equal to n. So starting with that and going to like the power of 2, it'd be like 8, and 8 minus 1 is 7, 10, next one would be 16, 16 minus 1 is 15, but it could be inclusive of that going up a level. So the question is how to find power of 2. I think maybe I can do log. There's quite a bunch of log functions in Python. I could do a for loop. I think log is probably faster. Let me think. I think it's like, I do have to worry about digital versus or decimal values with logs. I want to say, all right, let's just do the kind of let's do the for loop version since I know how that should play out. So let's say a equals 1. Let's say power equals 0 or 1? It's going to be 2 to the first minus 1. Power equals 1. While, I guess it might be 0. 2 to the 0 minus. While 2 to the power. I don't want to do exponentiation each time, actually. I just want to do doubling. Let's say power equals 1. While power is less than, okay, let's say this is value. Value is less than n. So this is going to be the 2 to the power minus 1. So it'd be value is equal to value plus 1 times 2. So first up is value is 1. Next time up is going to be 2 plus 1 times 2 is 4. Minus 1. Yeah. So next one up, value is 3. After that, 3 plus 1 is 4. 4 times 2 is 8. 8 minus 1 is 7. So while that is less than n, then keep on going. I think that's correct. Okay. I probably should figure out the logarithmic way of doing this, because there should be a log way of doing this. There's quite a few log functions though. There's math.log x and base. There's also math.log 2. There's math.log, or there's log 10 as well. I'm guessing I probably want to try log 2. How would I do this in log 2? So thinking of the example, I have 5 log base 2 of 5 is going to be like 2 and change, like maybe 2.2. So like 2 to the power of 2.2 is roughly 5, I want to say. And then 2.3. Okay. So what does that mean? So that means that I would round that up to 3, and then do 2 to the third minus 1 to get 7. And that's the general case. So like n is 10, log base 2 of 10 would be 3 and change, 3.2 maybe. 3.2, and then 2 to the fourth, which is 3.2 rounded up, is 16 minus 1 is 15. So that's probably works for non-edge cases, but edge cases are something like power of 2, or maybe power 2 plus 1, or power 2 plus minus 1, something like that. So if n was actually a correct value, like of the power of 2 value, like n is 8, log base 2 of 8 is 3. The correct value there should be 15, so it'd be 3, but if I can't round up on 3. 3 is 3. 3 doesn't round up to 4. So I think what I probably might need is I need to take the value of the input plus 1 value input plus 1, then take that as the argument for log base 2, and then round that up 2 to the power of that minus 1. And that should work for something that is the correct value. Like, let's say the correct value is already 7 as n. 7 plus 1 is 8. Log base 2 of 8 is 3. Round up is still 3. 2 to the third is 8. 8 minus 1 is 7. Okay. So I think this should be something like, I guess I could probably just do one expression, right? Log 2 of n, log 2 of n plus 1, round up. So I think that should be ceiling. So math.ceiling. Or is it math.ceil? Math.ceil. So maybe I should make this more explicit. Math.ceil, math.log base 2 n plus 1, and then take that as the power of 2 minus 1. Okay, well, possibly, okay, same speed, runtime. I'm assuming this would be slightly faster since it's not for loop. This somehow took more memory. 17.66. It's whatever. Okay. This is the direct calculation based on log. And this is a calculation based on finding best fitting power 2 minus 1. Okay. So alternatively, can directly calculate the return value based on logarithmic expressions. So for this this approach generally will be done using using logic based on correct input to output. So yeah, just trying to find this kind of expression that fits input to output is just like trial and error almost. General cases, like generally taking log base 2 of the input, generally using the round up value to take to use as the power, subtracting 1, and then doing edge cases and determine that the edge case makes it require the n plus 1. In any case, time complexity, this can be O of 1 for direct approach and O of log of n for the while loop, both of which are extremely fast. So runtime is like 0 milliseconds based on Python's calculations. That's the rounded version, I guess. If you look closely, it probably is some difference. Space complexity is going to be O1 since no additional space is needed.